So we're going to take a quick look at skin. Remember, skin is essentially an organ system because there are many different small organs found within it. And we said at the beginning of lecture that skin is for protection, sensation, excretion, temperature regulation, vitamin D production, and it also is a blood reservoir. So in lecture, when we went over this, we talked about the 3 different types of protection. There's biological protection in skin because some of the sublayers contain phagocytic cells. There are physical aspects of skin's protection because you have the stratified squamous epithelia where the cells are fairly waterproof. It can be thick, and so there's a physical barrier there preventing things from coming in from the environment. It did point out, however, that just because it's waterproof does not mean it's impervious to lipids, gases, or heavy metals. There's also chemical protection of cells in that there's a little bit of acidity and fatty acids to the secretions in sebum, and we talked about the fact that that's antimicrobial. Your skin itself slightly acidic, that's your acid mantle, and you even have melanin there to protect you from sunlight radiation. So temperature regulation is about activating the sweat glands. The sweat is mostly water and some electrolytes, and you move that to the surface of your skin because it takes heat with it. And so if you're going to get rid of a liquid, you might as well excrete at the same time. So temperature regulation is sweating, and sweating is also excretion. We talked in class and in lab about sensation because we have a lot of sensory neurons in our skin. Thermoreceptors here, my pointer, detect temperature, hot or cold. Meissner's corpuscles are the touch receptors. Nociceptors sense pain, and Pacinian corpuscles are deep and therefore pressure. Vitamin E production. Vitamin D is for cell division, calcium absorption across the gut, and maintaining calcium blood levels. We talked about that a little more in depth in lecture. Blood reservoir. Realizing that there's a part or a layer of our skin that has a lot of blood vessels in it. If you dilate or vasodilate a blood vessel, you make it larger, so more blood flows through it. You do this when you're hot, and at the same time you happen to be sweating, and that moves blood into the skin. When you're cold, you move blood out of the skin by vasoconstricting those blood vessels, and therefore less blood moves through them. So structure. Skin is an organ, so that definitely means there's more than 2 tissue types performing common function, and as most organs, it actually has all 4 tissue types inside of it. And because of all these different functions, we expect to find layers. Skin has 3 layers, as we learned in lab and lecture. The outermost layer is epidermis, that's epithelial. The deeper layer is the dermis, it's connective. The deepest part technically isn't a layer of the skin at all, it's adipose tissue, it's for shock absorption, and that's the hypodermis. Our epidermis, if we look at it, remember it's epithelial tissue. It's fairly avascular, although it's close to a blood supply. We say that the cells are keratinized because within them is a lot of a protein called keratin, and the cells themselves are called keratinocytes. Keratin is at their surface will make them hard and waterproof. It is stratified squamous epithelia, and its main role is protection. The epidermis has sublayers. The first sublayer that sits on the basement membrane responsible for division is the stratum basal. The cells that are created here are pushed through the remaining layers. The next sublayer is called the stratum spinosum. You can see that these cells are starting to form tight junctions or desmosomes with each other, so they're starting to form cell connections. They're also starting to flatten out and become more squamous. That sublayer is the stratum spinosum. Stratum granulosum is the next sublayer. The cells in here are making a form of keratin. It's called prekeratin, and it's in granules. It picks up stain. So they stain grainy or dark under the scope. The last sublayer in your hairy or thin skin is stratum corneum. These cells are totally dead. There's many, many layers of them. And again, they're hard and waterproof relatively. If we go back to these sublayers, we'd see that here's the keratinocytes responsible for division in the stratum basal and producing keratin later on. Here's a melanocyte. They're responsible for secreting melanin, which is these blue granules you see. Blue on the model, not blue in real life. And the melanin is absorbed into the keratinocytes. That's for protection against radiation from the sun to a degree. We have Langerhans cells. Langerhans cells are phagocytic cells within that stratum spinosum that provide a biological barrier. And we have Merkel cells here. Merkel cells are another kind of touch receptor. I'm not going to go through it because I kind of just did. But you should sit with this and you should be able to go through all the sublayers. You should know which one is in thick skin, but not on the previous slide that was thin skin. You should be able to characterize each of the sublayers, know what tissue type it's made of, and what its function is. Now the deep layer of skin is dermis. The dermis is more flexible connective tissue. The principal cells here are fibroblasts, mast cells, and macrophage. Because part of this is areolar, the other part of this is going to be dense irregular. So the dermis has two sublayers. The superficial sublayer is called the papillary sublayer. It's areolar connective tissue. Its hallmark are these dermal papillae. Within the dermal papillae, you'll have specialized capillary beds. Those are the loops. You have the corpuscles, and you have some free nerve endings. And there it is. The next sublayer is called the reticular sublayer. It's pretty much 80% of the thickness of skin. It's dense, irregular connective tissue. It has a lot of sensory endings in it, especially the deep pressure receptors. It's also where the active parts of all the appendages and glands for skin will be found. And then, of course, we have the last not really a layer, but component called hypodermis. Remember, it's adipose tissue, and it's there for shock absorption. So there is a little difference between layers and sublayers. We also had some fun in lecture talking about the pigments of skin. Melanin is essentially the normal pigment everybody has. We all have about the same melanocytes. It's just some of us, because of our genetics, they're a little more active than others. All of us go into the sun, they'll become more active than others. So melanin tends to pigment the skin in shades of brown. We talked about this gentleman getting a little into the carrot juice so you can see orange. Because, and he's fair-skinned to begin with, because the keratinocytes in the epidermis, other than melanin, are pretty much clear. In folks who are fair-skinned, whatever gets stored in the fat and the hypodermis is going to show through. So in this gentleman, the carotene, the orange pigment of the carrots, had been stored in the little hypodermis under his skin, and you can start to see it through. That is reversible. And I said in lecture I didn't have a good picture of someone blushing, but when you blush, it's because of hemoglobin. Hemoglobin is the pigment in blood cells that makes them red. So when you put blood into the dermis of the skin, again, it can show through depending on how much melanin there is, and someone is red tinged. And then we had fun talking about the blue man who got a little too into colloidal silver for too long of a period of time. His skin is blue now, but he likes it that way, and that is not reversible. So then after that fun conversation, we went into the appendages of skin. Skin definitely has sudoriferous glands in it, or sweat glands. We said the ones that you're born with, present in your palms of your hands, soles of feet, your forehead, and that are for temperature regulation, are your eccrine. But you also have this group called apocrine. They're in your axillary and anogenital regions. They're the ones that become active at puberty and are probably more about scent. So there's a sudoriferous gland. Now, if you take a sweat gland during embryonic development and it gets modified, you can get these other two glands. Mammary glands are obvious. They're the ones that secrete milk. Ceruminous glands are the ones in the ear canal, and they secrete cerumen, which is earwax. Now, in addition to sudoriferous glands, we have sebaceous glands. Sebaceous glands secrete sebum. Sebum is the oil that's meant to lubricate and soften the skin, and that prevents it or minimizes injury. And in lecture, I talked about the fact that if your skin gets really dried out, it tends to crack. We also had fun talking about hair follicles and hair. I'm not going to go through it now, but you should stop the slide and translate this to what we learned about in lab as far as hair follicles are concerned. Where do they sit? What are their parts? What's the tissue made of? Inside every follicle is a shaft of hair, and we talked in lecture about the fact that it's three layers to it: medulla, cortex, and cuticle. And then it's colored by melanocytes, except in redheads, in which it's not melanin at all, it's a different molecule. Hair is there for warmth, protection, and even sensation. We talked in lecture also about the fact that there's different kinds of hair and why the hair on your head, on your scalp, is longer than the hair that is your eyelashes and eyebrows. There's a cross-section through the follicle. Again, you should stop the slide. You should go through its layers and think about where this is sitting and how hair is hormonally controlled. And remember, we went through all these fun hair facts, which I won't test you on. So that is our quick review of skin.